Hello everybody. In this video session we will solve the second problem on series and parallel connection of resistances. Now here this is the problem statement. Three parallel connected resistors when connected across a DC voltage source consume a total power of 72 watt. Total current is 6 ampere. Current through first resistor is 3 ampere and second and third resistors are of equal value. What is the resistance of three resistors? So usually in such a problem circuit diagram is not given, so our first step is to draw the circuit diagram. Now, as you can see from first line, three parallel connected resistors. Now here there are three resistors which are connected in parallel. So first we will draw the circuit diagram. So three resistors are there which are connected in parallel. Now let us call this resistance as R1, this resistance as R2, and third resistance is R3. When connected across a DC voltage source, meaning across this parallel combination there is a voltage source which is of DC nature. So this is our circuit diagram. So three parallel connected resistors connected across a DC voltage source. Now let us call this DC voltage source as V. Now what they have mentioned, they consume a total power of 72 watt. Now if you write the given data, so what is mentioned here, total power consumed by three resistors, it is 72 watt. So PT, it is 72 watt. P stands for power, T stands for total power consumed by all three resistors. Total current is 6 ampere. Now here total current, it will be this current supplied by the source IT. So this total current, it is given as 6 ampere. Okay. Now this total current is also sometimes called as the supply current or total circuit current. Now what is next step, next quantity they have mentioned, current through first resistor is 3 ampere. Now if you assume current through resistance R1 as I1, so this current they have given I1 as 3 ampere. Now next what they have mentioned, second and third resistors are of equal value. So what it means, R2 is equal to R3. Second and third resistors, they are of equal value, and what we have to determine, what is the resistance of three resistors, meaning is that we want to calculate R1, R2 and R3. Okay, R2 and R3 will be same, so we have to determine R1 and these two resistances. Okay, now how to solve such type of problems we will see. So first step, we have to draw the circuit diagram that we have drawn already. Now look towards the given data. Now here total power is given, total current is given, and current through first resistance is given, and remaining two resistors, they are of equal value. Now here what next step we have to do, so based on the given data we should try to determine the unknown quantities. For example here PT is given, IT is given, so by using this PT and IT, what next we can determine. Now we have four formulae for power, basic fundamental formula for power. So power is given by V into I, or power it can be given as I square into R by Ohm's law if you put V equal to IR, or by Ohm's law if you put I equal to V by R, power will be V square by R. Now here whatever power is given, it is total power. Now if you want to write formula for total power, so PT will be equal to, now voltage for parallel it will remain same, so there is no need to write VT, but current, it is the total current. Now this formula we can write IT square into R. Now when total power is given, it means we have to consider the total resistance or equivalent resistance. Now here it is V square divided by R equivalent. Now we have three formulae for power. Now here which quantities are given? So total power is given 72 watt, total current is given 6 ampere. So based on these two, what we can determine here, we can determine the voltage, supply voltage, as well as we can determine the equivalent resistance. Now PT, we will use first formula. So PT is equal to V into IT, that is first formula. So from this, what will be the supply voltage? So total power, it is 72 divided by total current, it is 6. 72 upon 6. So V will be equal to 12 volt. Equation number 1. Okay. So from total power and total current, we can determine total voltage. Now while solving such problems, so there are more than one ways to solve the problem. Now we will see the simplest way to solve the problem. Now here total voltage we have got as 12 volt. Now how we can make use of this total voltage? Now as you can see, voltage across all the resistance, it will remain same as 12 volt. Now current flowing through first resistance is given, that is I1. Now we can determine R1 by applying Ohm's law. Now if we apply Ohm's law, so by Ohm's law, R1 will be equal to V upon I1. That is the very fundamental equation of resistance by Ohm's law. It is voltage upon current. But here what care we have to take? Resistance, if you want to determine resistance R1, we should know how much is the voltage across resistance R1, which is V, and how much is current through resistance R1. So we have to consider I1. So we should not write R1 equal to V upon IT. That is not correct, because we are interested in R1. So we should know how much is voltage across R1 and current flowing through R1. Now we know value of voltage 12 divided by current flowing through first resistance, it is mentioned, it is 3 ampere. So R1, it will be 4 ohm. Let us call this as equation number 2. That is our final answer. R1, it is 4 ohm. Now next we have to determine R2 and R3, both are equal value. Now there are number of ways to determine R2 and R3. Now one way what we can do, now as you can see here, total current, it is mentioned as 6 ampere. Total current, it is given as 6 ampere. Out of that 3 ampere is flowing through R1. So current flowing through R1, it is 3 ampere. Now if this is the 6 ampere, out of that this is 3 ampere. So how much will be this current? By applying KCL. So incoming current is 6, out of that outgoing is 3. So this current, it will be again 3 ampere. Okay, because 6 minus 3, it will be 3 ampere. Now I will just write 3 ampere here. I1 equal to 3 ampere. Now here 3 ampere, when it reaches this point, some current will flow through R2 and another current will flow through resistance R3. Now if you observe carefully, R2 is equal to R3, meaning opposition offered to this current, it is equal. Now when two equal resistors are connected in parallel, and if total current is I, then current flowing through each resistance, it will be I by 2. So that property we can use. So if total current is 3 ampere, so some current it will flow, that will be 1.5 ampere, and remaining current will be 1.5 ampere. So how we come to know this is 1.5 and 1.5? Because R2 is equal to R3. If R2 and R3 were not equal, we cannot write 1.5 ampere and 1.5 ampere current flowing through R2 and R3 respectively. Okay. So therefore, as R2 and R3 are equal, current flowing through each resistance, it will be divided by half. So 3 by 2, it will be 1.5. Now we can directly determine resistance R2 and R3. Why? Because how much is voltage across R2? It is V, so that we have already calculated from equation 1, and we know current flowing through R2, that is 1.5 ampere. Now if you apply Ohm's law similar to R1, by Ohm's law we can write, by Ohm's law, R2 will be equal to V divided by I2. Voltage across R2 is V, current flowing through R2 is I2. Okay. Now here this current, it will be I2, whereas this current we will call it as I3, and I2 and I3 both will be equal. Okay. Now this will be equal to, now voltage as we know it is 12 divided by I2, it is 1.5. So R2 will be equal to 12 divided by 1.5 or 120 upon 15. So 15 8s are 120. So R2 will be equal to 8 ohm. Okay. Now how much will be R3? Again R3 and R2 both are equal. So we can write R3 is equal to R2, that is equal to 8 ohm. Okay. So we can determine R1, it is 4 ohm, R2 it is 8 ohm, and R3 again it will be 8 ohm. Now there is one more way to determine R2 and R3. Once we get R1 as 4 ohm, voltage as 12 volt, there is one more way to determine R2 and R3. So what is that way? We will see. Now we can make use of this equation, power equal to I square into R. Okay, I square into R equivalent. Now this is the second way, method 2. Already first method we have seen to determine R1, R2, R3. So second method, so as we know, power PT is equal to IT square into R equivalent. So from that we can determine R equivalent. So how much is R equivalent? It will be total power, that is 72, divided by current square, total current square, that is 6 square. So R equivalent, it will be 72 upon 36, that is 2 ohm. Okay. Now let us call this as equation number 3, equation number 4, and this as equation number 5. So R equivalent, it is 2 ohm. Okay. Now once we got R equivalent, we already know value of R1. Now we can determine R2 and R3. Why? Because these three resistors are connected in parallel, and we know the formula for equivalent resistance. So what is the formula? So since 1 upon R equivalent equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. That is the basic formula for equivalent resistance of parallel. As there are three resistors, so it will be 1 upon R1 plus 1 by R2 plus 1 by R3. That will be equal to 1 upon R equivalent. Now here we know R equivalent, it is 2 ohm. So that is equal to 1 upon R1, already we have determined, that is 4 plus 1 upon. Now R2 and R3, they are equal. It is mentioned in the problem. So R2 plus 1 upon R2. Now there is only one unknown. We can solve this equation to get R2. Now if you simplify, so 1 by 2 minus 1 by 4, it will be equal to 2 by R2. 1 by R2 plus 1 by R2, it will be 2 by R2. If you take LCM as 4, it will be 2 minus 1. So 2 minus 1 divided by 4, that will be 1 by 4, that is equal to 2 by R2. So therefore R2, it will be equal to 8 ohm. By taking cross multiplication, R2 will be equal to 4 ohm, and since R2 and R3 are equal, therefore R3 is also equal to 8 ohm. So R2 is 8 ohm and R3 is 8 ohm. So we can determine all the unknown resistors by different ways. So in first way, total current is 6 ampere. Out of that, 3 ampere current is flowing through resistor R1. So remaining current will be 3 ampere. As these two resistors are of equal value, current flowing through this resistor will divide by half. That is total current divided by 2. So that is 1.5 and 1.5. And by applying Ohm's law, we can determine. So R2 is 8 ohm, R3 is 8 ohm. And R1 already we have determined as 4 ohm. And the second way, method 2, from total power and total current, we can determine R equivalent. So R equivalent, here it is 2 ohm. So we know the another expression for R equivalent, that is reciprocal of resistance is they are additive in case of parallel. So 1 upon R equivalent equal to 1 by R1 plus 1 by R2 plus 1 by R3. Out of that R1 we have determined 4, R2 and R3 are equal. So we have got R2 as 8 ohm or R3 and R3 as 8 ohm. Okay. So there are more than one ways to solve such problem. We can solve this problem by Kirchhoff's law also, but this particular method, it is relatively easy to understand. So hope you have understood how to solve such type of problems on series and parallel. Thank you.